Where is it? Sorry. How did stop it? Stop it. Here. Yeah, you can try it.
All right.
Okay,
can you guys see my slide?
Cool.
Okay, got it. Thanks, Kevin. Yeah, and thanks, Edison, for your talk, and also welcome you as the first member in Hong Kong in CNCF. Okay, let me start. Just give you guys some update about CNCF and an overview. So actually, CNCF is under Linux Foundation. We are a non-profit organization. We start CNCF focusing on cloud native.
Can you hear me?
Yeah, I saw also the Top Gun.
Okay, yeah. I believe everyone see the Top Gun, right? That's like cool.
Yeah, it's cool.
Essentially, that's cool. Wait a second. Okay, let me know if you can see my.
I can see it.
Wait a sec. Can you see it?
Yeah.
Just make sure.
Yeah.
Oh, wait a second.
On board.
On board. Wait a second. Why? Wait a second. Obviously, for Microsoft is not sure how to use the Teams, the Zoom, right? Only use the Zoom. Anyway, okay, let's get started. Okay, let me present my screen. Okay. Okay. Here. Okay, I believe you guys can see the slide. Okay. So today's topic I will share with you guys about exploratory data analysis, okay, with the Python. Okay, let me quickly introduce myself and my role before we go into the topic itself. Okay, and again, good morning, everyone. Okay, my name is Eason. I'm working in Microsoft as a global technology strategist. My role is something like a Microsoft CTO to serve for our global strategic customers. Okay, on technologies, digital transformations, and innovations. And my specialized area on the digital application developments, data analytics, and the data science. And someone called it AI machine learning. And I'm an active contributor in the data analytics and the data science communities, including code repository, articles, and public speech as well. Okay, you can see my GitHub in here. Okay, my Medium blog posts. Okay, and you can check it out from my blog posts for latest information about the application development news. Okay, or my latest sharing on the code repository. You can feel free to check it out. Okay, let's go to today's topic. In today's agenda, I will just share with you guys 3 topics, okay? Actually, the first one is not a topic, it's a live demo. The first one, okay, why do we need to understand the data, okay? What is the exploratory data analytics, or why need to explore, right? So in the first topic, I will try to introduce why we need to understand the data. In the second topic, I will share with you guys how and what is the approach to perform the exploratory data analysis, EDA recording, okay? And then lastly, okay, I will show you the live coding demo. Okay, have fun. So why we need to understand the data, okay? So this is a very interesting diagram. I try to search, okay, in the Reddit, okay? Reddit is something like a HKOSCon or LIHKG in the US base, okay, it's not in Hong Kong, right? It's very classic, I can say meme graphic, okay, recently. Talk about what do company or people think about the AI machine learning looks like, right? Something like oversimplified, okay? As long as we get the data, and then we can build up a AI machine learning model, and then we can get the result. Most of the people, most of the company think about this, but in actuals, okay, it's not, definitely, okay? It's not, definitely it's not, okay? From the data, in the middle, data analytics and the science, and then we get the value. You can see a lot of the process is being involved before we getting the actual value, even the data itself, okay? We need to prepare something, okay, before we go into the data analytics and the science. The data analytics and science is take a long process and then come up as the value. Value is something like you can see, realize something recommendation engines, computer visions, okay, object detection, something. That's what we call the value, right? Even if the value, okay, a lot of the process is involved. Okay, let me try to share with you in very high level way in here. So let's talk about the data. Okay, the data. Okay, the data itself. Okay, we have normally I'm trying to summarize it is has the 3 process in here. Okay, product selection and sourcing. Okay, before we try to think about how do we solve the problem, AI machine learning, right? We need to clearly understand what kind of problem you want to solve, right? like I would like to forecast the sales, forecast your stock price, forecast your cryptocurrency price. Okay, this is a problem you would like to solve, right? Okay, and then focus on the problem. Okay, we need to select, okay, and source your required data. At least, for example, taking stock price predictions. Obviously, you need to get a historical stock price, right? But denominated to that, okay, because you understand, okay, the stock price is not just a linear relationship to forecast the numbers, okay. We need to select, again, source multiple dimensions of the data, okay, to try to make your model, make your results, okay, more accurate, okay. After that, okay, we have selections, okay, we have sourcing the data as well. We need to do the synthesis, okay? Merging, something like in a simple way to understand, right? The blend all the data, okay, together, okay? If the one single wheel to try to start the analysis. That's the first step for the data. We need to understand the problem, okay? Collect the necessary data, okay? Sourcing the data definitely, okay? Before we go into the next step. The next step is data analytics and data science, okay? And today's topic, exploratory data analytics, is focusing on these areas. Data engineering, okay? In two steps, okay? Data analytics and data science. I can say it is blended together, it's combined, okay? Without the data analytics, exploratory, we have no AI and ML, okay? Because, okay, we understand that, okay? The AI machine learning, okay, is heavily required the data, okay? To do, to train the model, I can say as a fill, I can fill of the data, of the AI ML model in here, right? Let's take it step by step, okay? After we prepare the data, we source the data, a lot of data, we need to explore. Explore the data, find some clue, find some insights from there, okay? And then we can do some cleansing because we understand that the data, a lot of now value in there, okay? Data is missing, okay? Maybe not normalized it, okay? A lot of the problem. We need to take the cleansing before we going to actual doing something analysis. This is the combined process, exploring, cleansing. When you during the exploratory process, during the demo I'll show you, okay? During the exploratory process, you will find some of the data is so weird. Why some data is not labeled in there? It's something like a fee tax. So why the number is so distributed, okay? Why so much deviations in there, right? So we also need to take a normalize and cleansing as well in here together, okay? With this process, okay? Exploring, cleansing, normalizing, okay? I can say try to say it's something like a exploratory data analysis. Okay, it's an industry term already nowadays. After that, wait a second. I got some problem on my laptop. Wait a second. Just blank.
It's
Can you
back.
see my? Okay.
It's back.
Just blank. Okay, to fulfill. Just blank. Okay, maybe somewhat problem with my laptop. Okay, time to change the M2. Okay. Okay, I believe you guys, you can see the screen again, okay? I talk about the data engineering part, exploring, cleansing, normalizing, we summarize it as the exploring data analysis and here, right? After the process, okay, we have a more understanding and picture of your required data, okay, of your data you're sourcing, right? Something like a stock prediction example, you try to grab all the historical data of the stock performance, okay, or related stock price, you call together, explore it, to fill the bank, and then try to clean the data, normalize the data you have done. Okay, that's the process of EDA, right? After that, okay, you can do the feature engineering, okay, to try to figure out the relationship, the target results, okay, and to figure out what kind of features, okay, or sometimes, okay, the feature is not very obvious. You need to make the feature up, okay, we call it feature engineering. After the feature engineering, scaling, okay, scaling is also important before we going to the modeling, okay. Now this is a great step for the modeling. Definitely, we understand what kind of model, okay, you need to select, okay, something like, is this the classification problem, okay, is it a regression problem, okay, is this the time series forecasting problem, okay. Based on the problem you want to solve, okay, we need to select corresponding model before you're going up to for the training, right? Based on the technique, based on the experience, okay, you can you can very easily to select the corresponding model you would like to apply, or you record the algorithm in here. So you can start the training. Definitely from the training itself, okay, just few lines of coding, because we have a lot of the great, like a TensorFlow, like all the great framework or library, we can make the model training more easily. And then definitely you need to take the evaluations to see the result after training, okay? We need to select result, okay? Then see the result, is it good or not? If not, okay, you can try and errors in here. It's an iteration process, okay? Try to select different model, different algorithm to see the performance. It's an iteration like a circle in here. Keep training, keep evaluate, keep change the algorithm, and then see the result. And definitely you can see, find something like the model is selected soon is Y, okay? We should going in that way, okay? We can perform some tuning. We call it, or someone called it hyperparameter tuning, okay? Based on the very cyclic parameter, I'm gonna try to explain very detailed in the hyperparameter in here, just like a switch, okay? Something like old days, a TV, right? To try to receive a TV signal in here. You can imagine in TV, so many tuning unit in the bottom. Try to tune and receive the picture, okay, from broadcaster, okay, more clearly. Just try to slightly tune the value, and then you can get the picture more clearly. Something like this, the tuning. After that, okay, you accept the result, okay? In data science and data and machine learning world, we have no 100%. If you get a 100%, that's a good, no, it's not a good signal. That means bias, right? Obviously, we call it bias or overfitting something, right? So after that, after the training process, we can get a value, okay? We can say it, operationalize it, okay? After we train the model, just like a file. How do we serve the model to our customers, to your applications, right? In here, okay? That's the process. We need to register, okay? We need to register your model in somewhere, okay? Before we go into deployment. And nowadays, okay, we call it model registry, okay? We can register to somewhere, okay, as a model registry. The concept is something like a Kubernetes, okay? I hear the phrase sharing before this session, the Kubernetes. Obviously, the concept is more or less the same, right? Something like, when we deploy a container to the Kubernetes, obviously, we need to have a container registry in there, no matter what kind of brand, right? Just register to there, okay? We call it registrations. And then correspondingly, we can deploy your model, okay? Obviously, nowadays, we would deploy the AI machine learning model in the serverless way, is most common, okay? Or deploy in containers, okay? It's also possible over the AKS, over the Kubernetes server that, okay? Or whatever is the platform as a service, Kubernetes service, also possible. Obviously, the next time, okay, is about the monitoring, okay? We would like to know, okay, what is the effect, okay, of your model? Let's say the recommendation model, okay, I recommend you buy something, okay? Is it really effective? We don't know, okay? Before we roll out to end customers, right, okay? We need to continuously listen to the feedback of the end user results, okay? And then collect that results as a retraining sample to continuously improve our AI machine learning model, okay? We also call it a feedback loop. Or try to say, someone said it's buzzword or digital feedback loop to something, okay? It's something like receive the feedback from the customers, again, from the fundamentals, right? Receive the feedback, okay, of the model, and then continuously train the model and make your model more effective, okay, more accurate. And definitely, after we receive the result, okay, we cannot just one model because environment, the world, okay, is keep changing. No matter from the data, okay, from the environment, the world environment is keep changing, right? We know, okay, we need to retrain the model. That's what we call, okay, the value inside the value, okay, because we know that, okay. Let's say the model is trained by this year 2022, okay. Is it also applicable in 2023? Sort of, okay, maybe, okay, but you need to evaluate. Okay, make it operationalize, okay? And then with the new data, we can uplift and train the model to make the model able to fit for the next years or for next years, okay? That's a high level concept about the data. How about we convert the data? In the middle, we do a long process for data analytics and the science, and then become a value we can enjoy it. So at the bottom, okay, it sounds like very easy. We can get the data, right? In actual, it's not, okay? A lot of constraint in here, right? Okay, including, okay, the data analytic and the science process, okay? So many constraints for us and make us very, very hard to moving forward, okay? To source the data, do the modeling, and then we make it operationalized, okay? Something like a legal problem, okay? Are we allowed it to to provide such kind of information. Okay, when you think about the AI problem, okay, is it a legal terms conflict from your company, from yourself personally? Okay, is it conflicting something? The transparency, initial, okay, as well. Okay, is this something because the model? Okay, the people will hesitate. How do you get the data? How do you train the model? Why I need to trust your advice about the forecasting, right? The transparency is one of the important to make your model success, okay? This is the constraint as well. Definitely, the historical is biased, I can say, okay? Doesn't mean the data, as much as data we can get, okay? We can get higher accuracy of data. But in some times, okay, without the knowledge, without understanding, exploring, okay, the EDA process, we'll understand the data. We'll make the data without the cleansing, okay? Without taking out the deviations. We will make the model so biased, okay? If we're forecasting always going up, that's not a good sign, like last slide, right? Obviously, US stock price going down, right? If you try to using a very simple way, linear regression rate, to try to forecast the numbers, obviously, okay, you are going to die, okay, obviously, okay, trust me. Yep. And lastly, security, okay, it's very important, okay, because the data, okay, maybe in some cases, you will involve, okay, some of the personal information, some of the demographic informations, the genders, okay, the age range, okay, as well as so on and so forth. This is related to security. How do you make the encrypt your data, okay, before we go into train the model, okay, and then after the training model, how do we preserve? How do you protect your customer data as well when they input their value for the forecasting something? All the constraint. Sounds like a very difficult way, right? Okay, so that's why, okay, we need to take a very beginning step, okay, before we get the value. So that's why I'm trying to describe in descriptions of this topic. We need to take some things, okay, before we get the AI machine learning trainings, right? So, what? Well, I think, okay, my boring, right? Okay, so how do we do that? Okay, what? It's a long pauses, right? Let me talk about just coding some Wikipedia. Very simple. It's not writing by me. This wording, okay. The EDA, okay, it's not invented by me, obviously. It's a long time ago. Okay, it's John Turkey. It's born in it's 1917 already. Back to, okay, so many years ago. You know, okay. AI, artificial intelligence, machine learning, okay? Fundamentally, it's a statistical concept. It's a statistical concept, okay? And the exploratory data analysis, okay, is the fundamentally statistical skill. Previously, we called it initial data analysis something, but combine all the skill, okay? We try to relame it something, okay? Exploratory data analysis. And the guys, John Tukey already died, obviously. Try to define what is the define the process of EDA in here, right? In the bold text in here, try to summarize what is the what is the description of EDA in here. Exploratory data analysis is try to referring to the cuticle, it's a cuticle process, obviously, performing the initial investigations on the data. First step, we need to discover the pattern, discover any deviations, spot the anomalies, test the hypothesis, okay? Try to think about, is this something related like this? Try to test it in the data. Check the assumptions and make the summaries, the statistics, and using the graphical way to present. More or less, this is the process some of the analysts will be doing. Some of the analysts will be doing, okay? Maybe during the EDA process, you can cover your business questions so many business questions already because you really understand the data, right? And then prepare the good data, right? And then just last tips we hear, okay? Without the good data, we cannot make a very good AI machine learning, no matter how sophisticated algorithm or model you're trying to build, right? So before we go into demo, okay, before really go into demo, right? I would like to share with you what kind of tools we needed, right? What kind of tools we needed. Obviously, you need a laptop, Mac, okay, or Windows, obviously, or even Linux, okay, or Chromebook, or even, right? Okay, so you need the operation system, okay, in here, in the middle, okay. Obviously, you need to select a language, okay, in here, okay. Definitely. Nowadays, I can say Python is also dominant in the data analytic and data science role already, okay? Use the Python, okay? or in some cases, you can use the anacondas, okay? You can make the it's also Python, you can simple way to understand this, but you provide a virtual environment for you to make you more easily manage your overall Python training environments. Maybe next time I'm gonna try to share with you guys more details. I'm not trying to say it. Just imagine it's just a Python as well, okay? In some cases, okay, you need to make it scale, okay? The data, okay, maybe just 300 gig, okay? For example, using my laptop, it can be handled, okay? Maybe some of very small server can be handled, okay? In some cases, you need a distributed engine, okay? Nowadays, okay, we are not talking about the Hadoop anymore, okay? We are using Spark, okay? In the Spark, in the old days, we are using the Java-like language called Scala to try to do the analysis or do the exploratory data analysis or something else, right? Nowadays, we use the PySpark, okay? Python is also supporting the Spark as well, okay? So that means you can use the Python-like language to instruct the Spark engine, okay? Which is an in-memory basis data analysis engine. Definitely is horizontally, it's not vertical, okay? Horizontally distributed. That means your query will be super fast distributed to all the workflow, all the working nodes of the Spark, okay? And then come up with the results for you in here. So the coding language, obviously, Python, as I said, okay, because we have the environment here, okay, and the SQL, okay, the SQL language here, okay, very simple and understand, and the PySpark, as I said already, okay, or in some cases you can also use R, okay, but R, let's see what was there. I'm not trying to cover R, okay, and that's very Python-like already. I'm trying to build, but nowadays most of the library is supporting in the Python. I can say. It's almost dominant already in Python, really, okay? And most importantly, okay, the things, okay, we need not to try to do all the things from the scratch, okay? This is the beauty of open source, right? Because a lot of people try to contribute to open source library to make our life easier, make the data analytics, data science easier, right? Okay, something like a pandas. I'm trying to describe this is 4 key library. I will try to demo with you, very high level demo with you to show how do we do the exploratory data analysis, right? Pandas for the data analysis and the manipulating tools for the data cleansing, okay? This is a fundamental tools you must need to know, okay, before we're going to explore the data, including, okay, in the demo, I'll try to load a very simple CSV files, okay, and then do the analysis. After tools, I will load the CSV file, okay? After CSV file, I will try to clean something, explore the data situations. It's all pandas. So the next step, Matplotlib, okay? Matplotlib is very, very, very important library as well, okay? It can do static, animated, interactive visualizations, okay? Actually, before we having a very beautiful BI tools, this is intelligent tools, okay? Something like a Power BI, something like a Tableau. Obviously, okay, I can use a very simple, okay, in a coding way, okay, in Matplotlib, we very beautiful animated interactive tools for visualization purpose. But how do we relate to the EDA exploring? Because, okay, from the numeric value, it's very hard to figure out the cool, right? Figure out the trend, something. When we try to understand the data itself, obviously from the number, unless you are mathematicians, okay, you can figure numbers, are very sensitive on the numbers, that's fine, okay? In normal way, okay, we'll use the Matplotlib, plot the relationship, okay, of your data in the chart, pipe chart, okay, line chart, bar chart, whatever, to try to present it, okay, and to try to figure out what's going on, okay, in the graphic. So the next library I will share with you is the Numpy. It's very, very important library as well, the Numpy. Mathematical functions like the linear algebras, okay, random number generation in here. Okay, I use this Numpy very heavily, okay, in the daily basis. Okay, this is very important for to do the mathematical calculations. So the last thing, Seaborns, so important. I can say Seaborn is not an individual library. It is a library based on the Matplotlib. Okay, it's working together. Okay, Seaborn cannot live without the Matplotlib. Okay, but it can help you to put something like a very informative statistical graphics. Okay, specifically for statistical. Okay, I will show you right after. So at the top, okay, pre-trained AI model in here. Well, why do we need the AI model in here? Pre-trained it, right? Because, okay, we understand the data, okay, is some of the features, okay, with some of the features. Let's say why we need to computer visions, right? when we just back to the previous slide, just imagine back to the slide, the data itself. In the data, we have feed type, okay? Something like a structural data, or something like a CSV, formalized table, very easy to inject. You're not necessary to do the computations. Semi-structural data, something like a JSON, XML, okay? It's still a text-based, okay? We can extract it, okay? But in some cases, it is not. It's unstructured data, right? Something like a video, images, okay? Something like a voice scripts, right? You cannot directly do the analysis, right? We need to use you must necessary to use your skill to do the computer vision, very sophisticated computer vision model to try to extract the information. No, okay? There's a lot of pre-trained model in the world, okay? They're not necessary to train it. Try to extract the features, extract the information from the computer vision. Something like I would like to extract just like images with the product description somewhere. Why not we try to use the computer vision engines to extract the product descriptions, okay? And that the product description, we can do the further analysis for the textual analysis, right? This is a cool example. So how, right? Okay, before I will show the demo about how to do it, right? How to do it, okay? Before I'm showing the demo, really show you the demo, okay? I will tell you some tips, okay? Before we're going to fly, right? Okay, so what makes the successful EDA in here, right? So just my tips in here, just bear in your mind in here, okay? What make the EDA successful? Few bullets, okay? Understand the desired business outcome and goal, okay? We cannot just explore the data, okay? Keep explore the data. Just something like you work in Excel, okay? Keep exploring what is the objective, to be honest. Why you keep playing around the Excel file? Go to buy PS5, why do you play a game, right? Why you play Excel, right? So understand the business problem. Clearly understand the problem, decide outcome and goal. Otherwise, you cannot figure out what kind of data you need, okay? And what kind of things you need to explore, okay? This is very important. Maybe in the first step, okay, is keep changing. It's an iteration process, okay? You try to understand the data, okay? And then find out some clue, okay? Maybe extra data required. It's iteration process, iterative process. And definitely, we need your curiosity, okay? To try to, why the data something like this? You will require more and more data to figure out the clue. And the third point is very important as well, the industry and domain knowledge, okay? And the science, okay? And the science, okay? In old days, I'm working on the FSI sector. I have a great knowledge and the science on the FSI industry, okay? Now, okay, I'm taking care of another strategic customer in Microsoft, okay? Now I'm taking care of the retail sectors and the power utility sector and even the telco sector. Obviously, I'm not yet have the full much scan or sense on that industry, but okay, with the industry knowledge, with the technology knowledge, more or less a similar, okay? Definitely you need to sense based on the experience to try to figure out something, right? So let's go to the demo, okay? Let's go to the demo. So for the demo, okay, let me tell you the objective of this demo, right? I try to define a five objective in here, right? The first objective is try to figure out, okay, maximum of self, okay, what is the maximum standard deviation and so on and so forth, right? So let me open up in here, okay, before I try to explain what kind of things I need to figure out, okay? So this is a live demo. This is the Jupyter Notebook, right? After you install the Python environment, for example, if you would like to make your life easier, you can install the Anacondas, okay, with the Python. It will come with default. You will get the Jupyter Notebook in here, something like me in here. Don't be hesitant. It's very easy to use, okay? I'm trying to prepare the data. I'll try to handpicking some of the great examples from somewhere from Kaggle, okay? And then try to download in here for today's demonstration purpose. So let's get started from new. Okay. I just you guys can see the screen, right, Calvin? Can you see the screen?
Sure. Yeah,
okay.
See Jupyter.
Yes, perfect. Great. Okay. Let's go to hack, right? Let's fasten the seatbelt. Let's go to hack, okay? So, okay. I would like to, okay, as I said, okay, we have four very important library, okay, to use so in the EDA, right? Okay, let's kick started. Let's import the pandas. Okay. Okay, we normally we import the panda library. Okay, it's pre-installed. As long as you install the alpha counters, it's pre-installed. If not, okay, you can just very simple pip install pandas. Okay, very simple. Okay, you can do it. Okay, I believe you install with the under counters. You can very easily to import the pandas as PD. Okay, just the name. Okay, you name it. Okay, normally we import it as name it as a PD, right? So in here. So next step. Okay. That's a 10 pandas library. Oh, why my computer is always slow? Okay, perfect. Okay, okay. Let's define the data frame. Okay, you can name it. Okay, the data. Normally we use the DF. That means the data frame. Data frame in here. You can name it DF1, Eason 1, whatever. Okay, in today's okay, just call it DF. Okay, PD. Okay, call the library, and then they have break function called with CSV. Okay, okay. And then try to pop the path as well. Okay, sorry, I'm a bit lazy in here. What's the name? Yeah, let's copy and paste. Don't waste my time. Yep. Typo. Okay, just put your file's name in here, right? In the folder, okay, called data. In the data folder, I have the CSV file. Voila. Okay, and then you can load the CSV files. Okay. Very fast and easy, something like open Excel files in here. Okay, you can start to do the analysis already. Okay, let's call the data frame, and then let's call the headers. Okay, you can call the header is just first five row in here. Okay, you can try to change numbers, and then you can try to manipulate the top row in here. So I just try to show the top half. Okay, for first 5 row in here. Okay, let me try to, before we going to analyze the data, okay, let me try to describe the column, okay? When column, okay, the descriptions, the metadata, what is the store, what is the date, what is the weekly sales, what is the holiday fact, right? Actually, this data set is about the Walmart data set, okay? This is the sales performance of Walmart in US, okay? For the individual store, okay? From the 2010 to 2012 something. Okay, let's check it out. Okay, I also don't know, right? Let's check it out. I'll run something like this. Okay, exactly days. Okay, you can see the sales performance. Obviously, is it a holiday? What's the temperature? What is the fuel price? Okay, because in US it's crazy large. It's crazy far away from the supermarket, right? So I also this data set very interesting. Okay, you will also get the average fuel price of the week. Why we need to like that, you can imagine. So just try to imagine, okay, if the fuel price is crazily high, okay, obviously I don't want to drive to the supermarket to buy something, right? If the temperature is crazily high, okay, I won't want to drive to the supermarket to try something, right? Obviously, right? So in here, the CPI as well. Actually, this is a prevalent consumer price index. Okay, this is the price, prevalent consumer price index. Very from the economic perspective, I would like to know, is this related to the sales performance in here? And lastly, the unemployment, okay? And employment rate, it is also a economy perspective. Does the unemployment, okay? The prevalent unemployment rate, is it related to the sales performance of their Walmart sales? Okay, that's the descriptions of the data. Okay, and then now we understand the data column as well. So what kind of things we need to solve, okay, before we going to hack it out in here. We load the data, we see the header, we understand the column in here. So, okay, let's take a 5 problem, right? What's the 5 problem here? So, okay, first thing I think I would like to see which store, okay, which store, okay, has the maximize sales, for example. Okay, try to figure it out. Okay, maybe some of the business will be asked you already. Okay, this is your mandatory need to answer. Okay, not just train the model already, right? The second question, I'll try to, as an illustration or demonstration purpose, to try to figure out the maximum standard deviations of the store. Okay, that means the sales where we are low. Okay, from the very top to very low, well, like a roller coaster. I don't know why, but let's figure it out. Okay, so which store has the very good quarterly growth in particular quarters? The fourth problem I'd like to solve is, okay, try to figure it out, and I'm gonna try to solve, right? Some holiday, okay, because you can see the holiday flag, okay? is it impact to the sales? Okay, whether holiday sales is good there, okay, or give it a good positive impact or negative impact. I don't know. Okay, let's figure out together. Okay, and then provide a monthly. The fifth point is provide a monthly and yearly review of the sales and figure out the insights. I don't know. The monthly sales is good. Okay, the yearly sales is good. Okay, I don't know. Okay, let's figure it out. Before we go into to train the model, I will try to very quickly to show you how to train the model in just few lines of code in here. Okay, so let's go to the demo. So, okay, I love you guys. Okay, fasten your seatbelt. Okay, so let's explore the data. As I said, we need to understand the data before we go into exploring something. Okay, let's put a info. Okay, let's understand the data frame first. Okay, Pandas very easily. It's very helpful to help me to load the data itself, but we don't know what is the data type of the data, right? You can see the dates from here. Okay, we can see all the numeric value in actuals. What is the data type in the column? Okay, we need to figure it out. Okay, normally we will figure out something wrong. Okay, especially on the dates. Okay, in here. Okay, you can see the date is something wrong. It's not now perfectly. It's an object, or it's a problem object. Okay, it's not a. It's a wrong. Okay, it's a wrong data type in here. Okay, we need to change the data type to the date time frame. Okay, otherwise we cannot slot the data by the time series. Okay, we cannot slot the day, filter the date. Okay, it's a lot of. You can still do it to the analysis, but normally when we do it the analysis, we will change the data, change the column to the correct data type. Okay, before we go into analysis. Okay, there's nothing wrong. For others, I'm good for that. For the cells, okay, it's a float. Okay, perfect. Holiday, integer, reasonable. Okay, temperature. Okay, it's a float. Okay, no problem. All other no problem. Okay, let's go back. So let's hack on the date column. Okay, let's back to df. Okay, and then I will call the date column. Okay, very simple. The date column. Okay, let's make it something like a date in here. Okay, let's define something. Change the data type to very simple. Okay, in Panda, as a default library to do it here. Okay, as type. Okay, change to corresponding type in here. Okay, date time 64. Okay, that's the data type. Okay, you just remember it. Or if you don't remember it, okay, just Google it. Okay, that's as usual. So change it. Okay, we changed the data type already. Let's see any impact on the header as well. Is something wrong? Okay. Still here. Okay, the date is still here. Okay, obviously is the date, month, years, is now years, date, month, and the date in here, right? Let's go to the info again. What the? Okay, sorry. Yeah, info. Perfect. What the? Date. Okay, perfect. Okay, we can see the date column already changed to right to correct. Okay, to correct data type right in here perfectly. This is a very important step when we do the analysis. Okay, especially on the time series related data. Right, we would like to forecast something. In this example, I'm trying to forecast the sales performance. You try to forecast a stock price, crypto price. Same logic in here. So the next things. Okay. We understand that the now column, okay, maybe impact to the model, right? Impact to the analysis, okay. Obviously, you can use a very simple line to do it in here. Data frame, okay, is now value. All right, quick, always typo. Okay, as usual. Okay, reload and it. Okay. Very simple. You can see the benefit of a Python. Okay, very natural language to see. Okay, in the data frame. Okay, is there any now value? Okay, in any columns. Okay, in any columns. Okay, or in some cases I will use this as well as a tips. Okay, in here. Okay, just a summary. Okay, just summary. I would like to see any column. Okay, is containing just. What if, okay, we got the value is truth, okay? If it is true, that means some of the column contain a null value in here, okay? How do we know which column contain the null value? I need to figure it out, okay? Now, I can say we have 2 days, we are lucky, okay, in here, okay? None of column got the null value in here, or 0, okay? No here, okay? And then after you get truth in here, definitely you need to patch the data, okay? Or you clean the now row before we go into data analysis. Otherwise, okay, your data will be very interesting just there. Okay, another choose we try to do the EDA in here is try to describe, okay? Describe, okay? Describe is something like a info as well. It's doing a statistical analysis, okay, of your data, okay? Let's back to dates, right? I would like to know the date of the data frame, okay? When do we start, okay? What's the last record of the day of the record, right? Okay. In the statistical analysis, we can know that, okay? What is the highest value of temperatures, okay? What is the count, okay? You can see obviously the count is same here, right? What is the means of the standard deviations? What is the mean? What is the max as well? What is the 25% value as well, okay? You can see all the statistical analysis, okay? In this table, we can tell a lot of information back to your business already. You can see the data frame. From the first in here, okay? From the top, okay? From 2010 May 3rd, okay, and then to the 2012 12/10, okay, perfect, okay, that's the date, okay, that's the date range we would like to looking for. Okay, back to the first problem, okay, let's go to the figure out the tops, as I said, all right, 5 problem here, just recall in my memory, let's do something, right? The first objective we would like to figure out is which store has the maximum sales in here, right? So perfectly, let's call it T cell something. Okay, let's take it. No. Let's make it more meaningful. Okay, for illustration purpose. Total sales. Okay, we'll figure out total sales. Okay, let's make a. That's the benefit of Panda. Okay, something like Excel in here. Data frame group by. Okay, group by store because I would like to figure out store. Okay, and then figure out correspondingly weekly sales. Typo, and then figure out, okay, let's summarize, and then just I can try to rank it as well, okay, and then slot the value, okay, slot the values because I would like to figure out the top story in here, right? Obviously, something like Excel, just don't make it. If you don't remember such kind of the nine of the code, don't try to ask me in here, right? The documentation, just Google it, right? Don't need to forever memorize it. Okay. Don't try to do it. Okay. So that's the data frame. I defined it. Let's display it. Sorry for that. Okay, top 5. Okay, that's the top 5, or I'll try the top 10 here. Okay, so just top 20. Okay. With the weekly sale, that's the sum of the value of the weekly sales. Obviously, the top performance, the winner, okay, would be on the store 20, right, in here, right? So as I said, okay, matplotlib, okay, when we try to figure out the relationship, the statistical information, normally the number is not easy to find a clue in here, right? You report the data in the list bar chart in here, right? Or the night chart, wherever it is, right? For more easily, more effectively to figure out the clue in here, right? So, okay, I make a second example, a second step of example. I'm just using the pandas, okay, to try to plot the chart in here. Okay, let me try to. Panda actually also come with some of the out-of-the-box capabilities to report a very simple, I can say it's static bar chart, pipe chart, night chart is also fine. It's not too beautiful, okay, compared with matplotlib, okay? So it's also able to port, but this sample is so simple. So that's why I'm just trying to use this way to port the pandas. Okay, put, okay, obviously we need data, okay? The data source would be on the total sales I prepared, okay? I just want to put this data frame, we call it total sales because we prepared it, okay, I don't want to waste it, okay? So the port as a port, okay, a bar. This is not using the matplotlib, okay, just out of the box, Panda can do it, okay? Put the bar chart, firstly, you can use the night chart or whatever, but this time I like the bar chart. And then just one thing, okay, I would like to magnify it a little bit, although usually I love this number, okay, 88, okay. Okay, define the port, okay. Obviously, you need to define the title as well. Yep. I don't want to type it anymore. Okay. Okay, you can set the title very natural, right? You can see this function is very natural in here, right? Set the titles. Oh, sorry, my bad. Suspend the scope. Okay, top store of weekly sales in total, right? So obviously the XY label, right? Obviously you need to have it. Put is set X label. And then name it store ID. Or you get the store name, okay, reference it, okay, that's no problem. Okay, again, okay, obviously almost Y label. Y label will be sum of the weekly sales. Perfect. Okay, right here. That's the port. That's the port. Okay. They try to more easily when they send to the balls. Okay, something. Oh, this is the weekly sales in the bar chart way. Okay, obviously you can change the orientation as well. Okay, here more easy to figure it out. Okay, the top stock performance, right? Okay, here, right? And then you can figure it out the very top, the very low. You can almost see a 5th time performance with the lowers right in here. So, right, this is the first problem we have solved it. All right, right? So the next step, okay, I'm trying to figure out the standard deviations. Try to figure out the most deviated store performance in here, right? It's relatively simple in here, to be honest. Okay, something like okay. Okay, I call it standard deviation. Okay. If you don't understand standard deviation means, okay, just imagine something like a you can go to Wikipedia, obviously. Okay, try to see the log, the means. Okay, try the mini means. Okay, the variate with the average. Okay, that's the standard deviation in a simple way to understand, right? In the layman. Okay, data frame. Goodbye again. Okay, and then store. Don't try to make it wrong. Okay, this is real. Okay, this is real. We need to referring to the column lamps, weekly, sales, and okay, just one function in here. Okay, FTD. Okay, remember last time I tried to use the sum in here. Okay, actually this function is very powerful. Automatically help you to calculate the column standard deviation already. You need not any mathematics skill in here. Okay, obviously. Let's don't get so many numbers. Okay, round it to 2. Okay, as usual. Okay, slot value. Because I would like to figure out the most deviation one. So that's mean the SD, okay, the standard deviation, relatively large, okay, would be the variations, okay, very huge, right? So I would like to set the sending equal, I should copy and paste. Okay, no problem. Type it. Perfect. Some error. Typo again. Oh, and again. Okay, as I said. Okay, don't try to type it wrong. Okay. Okay. Type it wrong. The column name must be right. Okay. As you saw, head. The top 5. Okay. That's the top store. Okay. Got the deviations. Okay. 14, 10, 20 is the top 3 standard deviations. That's mean their store performance, the sales performance is deviates so much. Right? And the good news is I can tell the business, right? So the 20, okay, I know the 20 is very good performance, okay? Is it that we are deviate so much like a commodity cluster? No boss won't, right, obviously, okay? So that's why you can tell something in here, right? The standard deviations. So also Kelvin, just quick time check because I start late, right? Okay, in here. How many time I have? Okay, I just make sure I can.
You already expired.
Very good, very good.
Yeah.
I already know time, right?
Yeah, you're over time.
Overtime already. Okay.
Yeah.
So can I just would like to show one more step in here?
Yeah.
Okay. Yeah. Okay. Okay. Just show one more step. Be quick. Okay. No problem. Okay. Hope this is boring. Not boring. Okay. Okay. I would like to show. Okay. To understand the data. Okay. By the C bonds in here. Okay. Because I would like to know the data distributions. Okay. of the data before and going to, this is a very important step I would like to show and share with you guys, okay? To understand the data distributions, okay? And to make sure the data distributed evenly, okay? Before we go into the model training here, okay? And as I said, Seaborn is the guys helping me to doing something like this, okay? So, okay, I also need
Can you round up around 3 minutes?
Oh, yes, I can, 3 minutes, okay, I can. Okay, got
Thank
it.
you.
No problem, okay, no problem. Maybe I should have a next one, yeah, later. Wait a second, where is my cursor? What? Just copy and paste, okay, not necessary to make it fast, as I said, okay. Seaborn and Matplotlib is a border, okay, they need to working together, okay. So let's figure out the relationship between the data, okay, the axis. Okay, let's try to put something, okay. I'm trying to put the relationship I would like to show in here. That's very important step of the EDA in here, okay. Let's take it full. Okay. Structure, okay. You can define the DPI as well. Okay, DPI is 100, okay. Okay, let's figure out the detail. What kind of things you would like to figure out today is temperature. Okay, fuel price. I would like to see the distribution of the fuel price and temperatures, right? Okay. Okay, let's do examples. Okay, because I have 3 minutes. Okay. Okay. Okay, no problem. Let me try to finish, okay, before I try to explain, okay, what the heck are you doing here? Nope. Okay. Okay, that's it. Okay, explore the warning, okay? So this is the Seaborn's library. As I said, the Seaborn's library helps you to understand the plotting a data, okay, with the statistical view, right, in here. So that's why I'm trying to import the Matplotlib, okay, the first thing, okay, this is we need to import together, and then the Seaborn as well. And then Seaborn functions help me to pull the distribution of the data in here. You can see the temperatures, okay? You can see the deviations. Very easily to figure out deviation in here. For the fuel price, okay, it's normal, okay, it's normally distributed, okay, no problem, okay. I need not to do a further data cleansing in here. So because of the time, okay, thank you again for Kevin inviting me to share in today's, okay. You can see the demos, okay, from here, okay, and let's bring it together as open source, okay, because today is the open source communities event, okay. I would like to invite you to join us, okay, as an open source contributor. As long as you have great ideas, okay, great code sample library, okay, together as me as well, you can see all the great data scientists, okay, top contributors of Python, Pandas, whatever, okay. I'm part of it, okay, to try to contribute in the communities. If you have great ideas, okay, we'll try to contribute in the open source community, because open source, we know that open, cooperative, and flexible in here, right? So last but not least, okay, in here, in today's demo, okay, I already push it, okay, to my code repository, okay, just check it out, okay. If you like it, give me a star in here, okay. And right after, okay, I will try to also publish this demonstrations as a Medium post as well. Check it out, okay. And last but not least, okay, here's I also formulated something like Kelvin in here, right? I formulated an AI communities in here. If you would like to join, okay, to ask something to connect with our group of the AI specialists in here, okay, join the Discord, okay. So feel free, okay. Sorry for overrun a little bit, okay. So thank you, Calvin. Time back to you.
Thank you, Eason. If you have some question, you may list in the chat room because it's already overrun. I think for live coding, live demo is very hard for everyone. It's hard to make a time management, and so it's okay. So thank you, Eason, again. So that the next session I will pass to my teammate Justin about the Amanda session. Justin, are you okay?
Yeah, sure. Thank you. Hi, everyone. I'm Justine Tai. I'll be the MC for the next two sections. So the first one start with a topic relevant to all of us. Is about building your smart home with Home Assistant. As more of us are spending more time working from home, so how can we save more energy and save time? So I'd like to introduce the background of Amanda. Amanda is an active contributor and organizer in application of emerging technology